Hello and welcome everyone. Myself Vinay Yadav, mathematics mentor. Hope you guys are doing amazing. So today we are going to have our discussions on the important points related to triangle. It may lie inside a triangle or outside of a triangle. So these points are going to be very much important because when it comes in terms of coordinate geometry, as we are going to have our problems based on those topics. It may be included in the problem. So what are those topics? Let me first summarize those topics which we are going to have our discussions in today's class. So first of all, we are going to have our discussion on the topic centroid, and the second topic is going to be incenter. And the third one is going to be excenter, and the fourth one is going to be orthocenter, and the fifth one is going to be circumcenter. So these are the 5 points which lie inside or outside of a triangle. We will see whether it lies inside of a triangle or outside of a triangle. Based on that, we will be discussing all the important points. We will be solving some problems based on these points which lie inside a triangle or outside of a triangle. So before starting this one by one, we will be discussing some of the prerequisites which will be very much important while going through these topics. So let us understand what are those prerequisites first of all. After that, we will move further. Prerequisites are: first of all, we must be very much aware of what is median. So first prerequisite is going to be what is median, and the second one is going to be what is angle bisector. When it comes to angle bisector, it may be internal angle bisector or external angle bisector. So we will be taking two parts here. First one is going to be internal angle bisector, and the second one is going to be external angle bisector. And the third point which we are going to have discussion is angle. First of all, we will discuss what is angle bisector. Based upon that, we will be discussing what is angle bisector theorem. So we will be discussing angle bisector theorem. These are the topics of previous classes, so we will recall it so that it will be easier for us to move in our class. And the last one we will discuss about midpoint theorem. So these points are going to be discussed before starting our main topics, that is what is median. So we will discuss one by one. So when it comes to median, so first of all, let me tell one thing, that all the points which we are going to discuss in today's class, that is whether centroid, incenter, excenter, orthocenter or circumcenter, all these points are going to be discussed for any kind of triangle. It doesn't rely to any scalene triangle or any isosceles triangle or equilateral triangle. Irrespective of any nature of the triangle, we will be discussing all the topics for any kind of triangle. So what is median? So median is basically, suppose when we are drawing from point A, we are taking the midpoint on, suppose we are taking point A and we are taking midpoint on the opposite to point A, that is we are taking midpoint on side BC, let's say it is D. While joining the point A and B, we will be calling it as median. So what median does is, when we are drawing median from one point to opposite to its opposite side, we will be getting point D as it is a midpoint of point BC, side length BC. It means is median divides the opposite side into equal parts. Similarly, if you divide median from point B to opposite side AC, it will be dividing AC into two equal half. That is, let's say it is E, then AE will be equal to EC. Similarly, when we will be dividing our median from point C to opposite side length AB, then we will be getting, let's say it is F, then CF is a median. So here AD, BE and CF are medians. So what happens is, whenever we will be dividing line, and whenever we will be drawing a line from point or any point of a triangle to its opposite side, we will be getting that it divides the opposite side into two equal halves, and that side length, that line segment is known as median. So in this triangle ABC, AD, BE and CF are medians. So we know, we are aware of what is median does. Median basically divides opposite side length into two equal halves. So now we are going to have our discussion on the topic angle bisector. So as we can see here, angle bisector has been divided into two parts, that is internal angle bisector as well as external angle bisector. So we will learn one by one both the topics. See here, we are going to have our discussion on angle bisector. So these are very basic things. I need to recall it so that we can move smoothly in coming topics. So when it comes to angle bisector, so we have, let's say, triangle ABC. Likewise, we are drawing here. Let's say triangle ABC is being drawn here. As we can see that when it comes to this angle A and this angle B and this angle C, all these angles are going to be known as internal angle. If I write this, so angle BAC, angle ABC and angle ACB are internal angles. Similarly, when we extend this BC towards here, let's say X dash, and this one to this side X, and suppose this has been extended to here Y. So now we can see here this angle ABX, if it is alpha, then it is going to be pi minus alpha. We all know supplementary angle. If one angle is alpha and this angle is supplementary, it means that another angle is going to be pi minus alpha, because in supplementary angle sum of both the angles are going to be 180 degree. So here when we divide angle ABC, this one angle ABC, into two equal parts, that is, let's say this is point D, and when we are saying that BD is an angle bisector, what does it mean is this angle is going to be equal. Angle DBC and angle ABD are going to be equal. Let's say if it is alpha by 2, then it is also going to be alpha by 2. So BD is going to be known as internal angle bisector. Why? Because it is dividing internal angle into two equal parts. That's why it has been named as internal angle bisector. Similarly, if we divide angle ABX into two equal parts, if we have any line segment or any line which is dividing it into two equal parts, angle ABX, let's say this line is going to be divided into two equal parts. Suppose this angle is going to be equal to this angle. Then suppose this is line L. Suppose two points are there, M and N. Then M and is going to be known as external angle bisector. Reason being, it is dividing an external angle into two equal parts. Why it is external angle? Because we are extending side line BC towards left side, and afterwards we are knowing that angle ABX is going to be external angle. So if we write here, so we can write here as angle ABX dash, comma angle ACX, comma angle CAY are external angles. So now we are aware about basic things, that what is internal angle, what is internal angle bisector, as well as what is external angle and what is external angle bisector. If we have any line segment or any line which is dividing an external angle into two equal parts, then that line or line segment is going to be known as external angle bisector. So now this is clear to us. Moving to the next point which is required to be known to us is angle bisector theorem. As of now, we are now aware about angle bisector. So suppose we have any triangle ABC, and we know that angle line segment coming from point A to side length BC and point meeting here at point D, and we know that AD is an internal angle bisector. Then we know that this angle is going to be equals to, so angle BAD is going to be equal to angle DAC from angle bisector, because AD is angle bisector. So now what angle bisector theorem states is, as we all know that in triangle, by convention we use side length opposite to point A as with small a, and side length opposite to point angle B, that is AC is going to be side length is going to be B, and opposite to angle C, this is going to be length of C unit. So we have this A unit, B unit, and C unit as side length. So what does angle bisector theorem states? So here I am writing angle bisector theorem. Angle bisector theorem states that BD upon DC is going to be in the ratio of C raised to B. C upon B, that is point D is going to divide side length BC in the ratio of C raised to B. This is known as angle bisector theorem. Angle bisector theorem. So what does this mean is, when we have any triangle ABC and we have any internal angle bisector, let's say in this case it is AD, then side length BC is going, then point D is going to divide side length BC in the ratio of C raised to B, that is containing side lengths, that is C and B. So here we are now known about angle bisector theorem, that if you have any angle bisector in a triangle ABC, then point D is going to divide the side length BC in the ratio C raised to B. What is C and what is B? C is the side length opposite to point angle C, and B is the side length opposite to angle B. This is all about angle bisector theorem. Now the next point is midpoint theorem. So we are already aware about midpoint theorem. I am recalling here because we are going to take use of midpoint theorem also. So understanding once is important. Let's say we have a triangle ABC, A, B and C. So what does midpoint theorem states? That if we have any triangle ABC or any triangle, whatever the name is going to be, and we have two midpoints on any two sides. Let's say we have two midpoints. Let's say E and F. E and F are going to be the midpoints of side length AC and AC respectively. Then if we have two midpoints, when we join these two midpoints, let's say when we join E to F, then it is for sure that EF is going to be parallel to BC. This is the first conclusion of midpoint theorem. Here I am writing the point topic as midpoint theorem. Midpoint theorem. So if we have two midpoints of a triangle if we have two midpoints on the side lengths of triangle ABC, when we join those two midpoints, then we are going to say that let's say EF is going to be parallel with BC, and the second one is going to be EF is going to be the half of side length of BC. That is, BC is going to be twice of EF, and these two line segments are going to be parallel. This is the conclusion of midpoint theorem. So now we can move further to our main topic, that is centroid, incenter, circumcenter, excenter and orthocenter. So after having this much of knowledge, now we can move smoothly. Let's say we are going to have our discussion on the first topic, that is centroid. So centroid in any triangle, we have if we have any triangle, then centroid, what is centroid? It is the point of intersection of medians. Suppose we have a triangle ABC, let's say XYZ. We have been taking ABC so many times. So let's say we have a triangle XYZ and we have any median. So already we have discussed what is median. So median is the point from originating from point X to the side length YZ at the midpoint. When we join the midpoint of side length YZ to the point X, then X, let's say it is X dash, then X dash are going to be median. Similarly, when we draw a line segment from Y to side length XZ to the midpoint of side length XZ, let's say this is the midpoint Y dash, then this intersection point is going to be known as centroid. Short form of centroid is going to be with G. So this point is going to be known as G. Similarly, when we draw median from point Z to side length XY, it will also pass with the same point, and this point is going to be known as Z dash, and Z dash is also the midpoint of XY. So this point of intersection is going to be known as centroid. So here G is centroid basically. So what centroid is? Centroid is the point of intersection of medians of any triangle. So here we can write centroid is the point of intersection Centroid is the point of intersection of medians of a triangle. Medians of any triangle. In this case, G is the centroid. Now we have known the definition of centroid. Suppose we will be having points x, y, z in terms of coordinates. Then how we will be knowing the points G? Suppose we have x coordinate as x1 comma y1, y coordinates as x2 comma y2, and z coordinate as x3 comma z3. Sorry, x3 comma y3. Then how we will be finding the point G, that is centroid? So for that we need to derive our coordinates for G. Let's see how we will achieve it. So before moving further, we need to identify that this point G, how in what ratio it is dividing x into x dash. Sorry, x dash. Let's say what I'm talking about is we need to know about the ratio. Let's say we have coordinates, points as A, B, C, and this is the median. AD is the median. Sorry. So this is also going to be, so G is the median. So now what our concern is, we need to know in what ratio this point G is dividing side length AD. Once we will be knowing this condition, in what ratio it is dividing, we can easily write the coordinates of point D. And we know that point D is the midpoint of BC. From there we can be able to get some of the conclusion for point G. So to understand this, what we will do is, let's say we will do some construction work. What we will do is, we will extend GD to point K, and we will join BK and CK. Here we are joining BK and CK. What we are going to achieve is, we are going to find the relation, or we are going to find the ratio in which point G is dividing side length AD. So here we have done, what we have done is, we have extended GD to K, and we are now joining BK and CK. So here from our construction, what we have assume is, from our construction we can say that AG is going to be equals to GK. AG is equals to GK. This we have extended K so that we can be able to write AG is equals to GK. From here, now D. So what we will do is we will see triangle ABK. Now in triangle ABK, what we can see is, we will draw, we have already one midpoint. Point G is the midpoint of AK. We have already taken. Now we will take point F as the midpoint of AB. In triangle ABK, F and G are midpoints of AB and AK respectively. So we have F and G as the midpoints of side length AB and AK respectively. So just observe this triangle only, ABK. What we are going to assume, this triangle is the only point of concern for as of now. So we know F and G are the midpoint, and as we have already learned about midpoint theorem, that if we have to, we have learned that if we have two midpoints of side length AB and AC, and we will join this, let's say EF, then EF is going to be parallel to BC. Similarly, we will apply the same concept here. F and G are the midpoint. When we will join this F and G, it is going to be parallel to the third side, that is BK. So basically FG is going to be parallel to BK. So from midpoint theorem, what we can say is, FG is going to be parallel to BK. Now FG is parallel to BK, and we know that we can, since G is a centroid, it means that it will pass through C also, point C also. because we know centroid is the point of intersection of all the medians of a triangle ABC. So G is going to pass through point C also. It means that if FG is parallel to BK, it means that FC completely is parallel to BK. Similarly, we can say that GC is parallel to BK. It implies that GC is parallel to BK. We have equation number 1, let's say. So basically GC is parallel to BK. Similarly, what we will do is, as of now we were talking about triangle ABK. Now we will be talking of about triangle ACK. So now we have point of concern about this triangle ACK. So we will have our conversation about triangle ACK. So about ACK, what we will see is, this is the point. This is the triangle ACK basically. So already we have point G as a midpoint of AK. We will take point, since we have already E as a midpoint on side length AC. So when we join GE, it means that G is parallel to CK. Similarly, we can write that in triangle ACK, GE is going to be parallel to CK from midpoint theorem. Similarly, we have discussed here. So G is going to be parallel to CK. Similarly, we can say that BG is going to be parallel to CK. It implies that BG is going to be parallel to CK. From, let's say, this is equation number 2. So from equation 1 and equation 2, what we can observe is, let me identify you. GC is parallel to BK. These lines are parallel. Similarly, it is saying that BG is parallel to CK. It means this line is parallel to this line, and this line segment is parallel to this one. It means that BGCK is a parallelogram. Therefore, we can write BGCK is a parallelogram. Since BGCK is parallelogram, we can apply all the properties of parallelogram to this BGCK. Now what we can observe, that we can apply the property of parallelogram, that we know that in a parallelogram diagonals bisect each other. What does this mean is, since BGCK is a parallelogram, it means that for this GK and BC are going to be diagonals. It means these are going to be bisect each other. What does this mean? GD is going to be equal to DK and BD is going to be equal to DC. We already know that D is a midpoint of side length BC. So clearly we can say that GD is also equal to, it means diagonals bisect each other. It represents that GD is equals to DK. Since diagonal bisect each other, therefore GD is going to be equal to DK, and BD is equals to DC. That we already know that. So from here, what we can achieve is, since GD is equals to DK, and we have observed that we have taken in as our assumption that AG is going to be equals to GK. So AG is going to be equals to, what we can write GK as GD plus DK. Now we can write AG is equals to GD plus, in place of DK, what we can write? GD. So what we can now write it as AG is equals to 2 times my GD. So basically AG upon GD is going to be equals to 2 raised to 1. So basically the ratio, point G is dividing side length AD, it is the ratio of 2 raised to 1. So we should remember this, that centroid of any triangle divides median in the ratio 2 raised to 1. We have already saw the proof. We should remember this one. Proof is not that much important, but the result is very much important, because we are going to use this result very often in coming problems. So this was the first time that we were discussing about this. So that's why I have let you understand the proof also. What we have done is, we have extended, let me summarize it. We have extended the point D to the point K in such a way that AG is going to be equals to GK. Now from there we will see the triangle ABK. In triangle ABK, what we have observed, that we have point F and point G as the midpoints of side length AB and AK. So applying midpoint theorem here, what midpoint theorem says, if we have midpoints of two sides in a triangle, then we can say that while joining those 2 points is going to be parallel to the third side. Similarly, we are applying here that FG is going to be parallel to BK. It means that GC is going to be parallel to BK. Why? Because since G is a centroid, therefore it will also pass through the point C also. So GC is going to be parallel to BK. Similarly, we have applied the same logic to the triangle ACK. From there, we saw that BG is going to be parallel to CK. Since we know that GC is parallel to BK and BG is parallel to CK, it means that BGCK is going to be parallelogram, and we will apply the property of parallelogram that diagonals of a parallelogram bisects each other. What does this mean is GD is going to be parallel equal to DK and BD is going to be equal to BC. And now we can write from our assumption, we know that AG is going to be equal to GK, AG is going to be equal to GK, and we can write GK as 2 into 2 parts, that GD plus DK. So in place of DK we can write as GD because we know that GD is equal to DK. So from here we can write AG is the twice of GD. We will be taking the ratio, that is AG upon GD is going to be 2 upon 1. It means that we will write the result here. What result we have approaches is centroid. We will write the result. Just let me remove this part. So after the derivation, we have came across one of the important result regarding centroid, that centroid divides median in the ratio 2:1. So centroid divides median in the ratio 2:1. This is the what we have derived already. So this is going to be the very important result. So now we know that centroid divides median in the ratio 2:1. So we are going to take use of this thing. We are going to take the advantage of the result which we have just derived. So now suppose we have a triangle ABC, and we know that AD is the median, that is, this is the midpoint of BC, and BE is also the median of side length AC. It means that A is going to be equals to EC. So now we know that G is a point of intersection of two medians, so it is known as centroid. And now we have the information that G divides, we know that G divides AD in the ratio 2:1. That is AG upon GD is going to be equals to 2 upon 1. And we know the coordinates of ABC, x1 comma y1. This is going to be x2 comma y2, and C is going to be x3 comma y3. So now what our target is, we know the coordinates of point A, B and C. We need to find the coordinates of our centroid, that is, we need to find the coordinates of point G. So we know that G divides side length AD in the ratio 2:1. We are going to take advantage of that. Before that, we know that D is the midpoint of BC. So we can easily write the coordinates of point D when we are knowing the coordinates of point B and point C, because D is the midpoint. So we can write coordinates of D as, so we can write the coordinates of D as x2 plus x3 divided by 2, comma y2 plus y3 divided by 2. Since D is the midpoint, so based on that we are aware of the coordinates of point D, and we know that G is the point which is dividing AD in the ratio 2:1, which is dividing AD in the ratio 2:1. And also we know the section formula which we have already discussed in the previous class. So applying section formula on the side length AD. So now what we have a side length AD. I'm taking this picture here. So we have G as the point here. We have point G which is dividing in the ratio 2:1, and coordinates of A is x1 comma y1, and coordinate of D is x2 plus x3 divided by 2, comma y2 plus y3 divided by 2. And we need to find the coordinates of point C. Now this is a section formula question. We need to solve it. Take it as x comma y as the coordinates of point centroid. So we can write applying section formula. Applying section formula. What we can say, point x is going to be equals to 2 times multiply by x coordinate of point D. This 2 is going to be multiplied with x coordinate of point D, that is 2 into x2 plus x3 divided by 2 plus 1 into 1 into x coordinate of point A. This is going to be multiplied with this. 1 is going to be multiplied with the x coordinate of point A. So 1 is going to be multiplied with x coordinate of point A, that is x. That is x1 basically, divided by m plus n, that is 2 plus 1. Here it is 3. So after solving it, we will be getting it as x is equals to 2 will be getting cancelled out. So x2 plus x3 plus x1. So basically it is x1 plus x2 plus x3 divided by 3. So we got the coordinate of point x. We got the coordinate of x coordinate of point G, that is centroid. So we now x is going to be equals to x1 plus x2 plus x3 divided by 3. Similarly, we need to find the coordinate of y. So how we will do that? We will apply the same formula in terms of y. So we can write it as y is going to be equals to 2 multiplied by y coordinates of point D, that is 2 into y coordinates of point D, that is y2 plus y3 divided by 2 plus 1 into y coordinates of point A, that is y1 divided by 2 plus 1 3. Similarly, we can see here y is going to be equals to y1 plus y2 plus y3 divided by 3. So now we have x coordinate as well as y coordinates. X coordinate is going to be equals to x1 plus x2 plus x3 divided by 3, and y coordinates is going to be equals to y1 plus y2 plus y3 divided by 3. So now onwards, if we have the coordinates of A, B and C, 3 points of a triangle, then we can easily write the coordinates for centroid. How we will write that? We have the formula x equals to x1 plus x2 plus x3 divided by 3, and y equals to y1 plus y2 plus y3 divided by 3. So suppose we have a problem. So we have derived how to find coordinates of a centroid when we know the coordinates of all the 3 points of a triangle. Very firstly, we have seen that in what ratio centroid divides the median. We have seen that it is dividing in the ratio 2:1. We have already seen the derivation part also. So knowing this result, we have calculated coordinates of point D. Now we have applied section formula over the point A and D, that G is dividing in the ratio 2:1. From there we can easily write coordinates of point G. So suppose we have any problem based on the coordinates, how we will solve it? So our first question based on the centroid is, we have point A, B and C of a triangle ABC, in which we have been given point A as 1, 4. So coordinates of point A is 1, 4, and the coordinates of point B is 3, -2. We need to find the coordinate of point C if centroid of a triangle ABC is 2, 3. So here we know the coordinates of A and B. We know the coordinates of centroid. What we need to find is the coordinates of point C. So as of now, we have seen that if we have points A, B and C of a triangle ABC, and the coordinates are x1, y1, x2, y2, x3, y3 respectively, then we can write the coordinates of centroid as x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. So we will apply the same result here. So what we can know that we know that if G is a centroid with coordinates x, y, then we can write it as x is equals to x1 plus x2 plus x3 divided by 3. Similarly, we can write y is equals to y1 plus y2 plus y3 divided by 3. So x1, x2, x3 is, so x is already been known to us. So x is 2. Since centroid is known to us, it means that x coordinate of centroid is 2. So 2 is equals to x1 is x coordinate of point A, x2 is x coordinate of point B, that is 3, and x3 is the x coordinate of point C, which is not known to us. So we will assume it as x3 divided by 3. After solving it, we have only one variable. We can easily solve it. What we should know, we will be getting 6 is equals to 4 plus x3. So from here we can write x3 is equals to 2. So it means that x coordinate of point C is going to be the 2. Similarly, we have the y coordinates of centroid as 3. We can write 3 is equals to y1 is the y coordinate of point A, that is 4, and y2 is the y coordinate of point B, that is -2, plus y3 is the y coordinate of point C, which is not known to us. We will assume it as y3 divided by 3. Here we will solve it. We will be getting as 9 is equals to 2 plus y3. From here we can write y3 is equals to 7. So the coordinates of point C is going to be 2 comma 7. It is 2 comma 7. Answer. Very basic problem based on the centroid. If we are known about the coordinates and the centroid, how we can deal with this is the solution. We have been known that if G is the centroid of a triangle ABC with coordinates x comma y, then we can write x is equals to, in terms of coordinates of triangle points A, B and C, that is x1 plus x2 plus x3 upon 3. Similarly, y in terms of y, we have just substituted the value which we are known and substituted the value as unknown variable which we are not known, that is in this case we are not known x3 and y3. So we have just put the value, we have solved it, we got the value of x3 and y3 as 2 comma 7. So basically the point C is going to be the 2 comma 7. Please note down it. So based on centroid, we have another problem here. So in triangle ABC, we have the coordinates of point A, B and C. Coordinates of point A is AB comma 1 by AB. Coordinates of point B is BC comma 1 by BC, and the coordinates of point C is CA comma 1 by CA, where ABC are roots of cubic equation, that is x cube minus 3x square plus 6x plus 1 equals to 0. Find the coordinates of centroid of a triangle ABC. So basically the same problem has been given on the topic, that we are aware of the coordinates of point A, B and C, and we need to find the coordinates of centroid. So we already know the formula. The only difference is here it is given in the terms of A, B and C, where A, B, C are the roots of the cubic equation x cube minus 3x square plus 6x plus 1 equals to 0. So what will be the approach of ours to solve this problem is, we will solve as we are knowing. So what we know that the solution is going to be, just try on your own first of all, afterwards see the solution. It will be more beneficial for you. So if G is a centroid with coordinates x comma y, so we know that x in terms of x1, x2, x3. So we know that x is equals to x1 plus x2 plus x3 divided by 3. So what is x1 in this case? X1 is going to be the x coordinates of point A, and it is x2. So x2 is the x coordinates of point B, and x3 is the x coordinate of point C. Similarly, we can write here x is equals to AB plus BC plus CA divided by 3. So we don't know AB plus BC plus CA. So what we know is relation between A, B and C, that ABC are the roots. So basically we have cubic equation x cube minus 3x square plus 6x plus 1 is equals to 0, and it has roots, let's say are roots of the ABC. So basically A, B and C are the roots of this cubic equation, and we know the sum of all the roots of a cubic equation, that is, it is going to be equals to A plus B plus C is going to be equals to minus B by A. So here minus B, so basically B is equals to minus 3, so minus B is going to be plus 3. So minus B by A, that is 3 by 1 equals to 3. Summation of roots taking 2 multiply by taking 2 at a time, it means that AB plus BC plus CA is equals to C by A. Here C is equals to plus 6, so it is going to be 6 upon 1, it is equals to 6. Taking all the roots, product of all the roots, that is ABC, which is going to be equals to minus D by A. In terms of this equation, D is plus 1, so minus D is going to be minus 1. So minus D upon A, that is equals to minus 1. So now we know AB plus BC plus CA, it is going to be plus 6. So from here we can write x is equals to 6 by 3, that is equals to 2. So x coordinates of centroid of this given triangle ABC is going to be 0.2. So we need to find the y coordinate also here. So how we will do that? So similarly, now we will write x is equals to 2. We need to find the y coordinates of centroid. So similarly we will do for y also. The knowledge which as of now which we are having, we will use that knowledge. So y is equals to y1 plus y2 plus y3 divided by 3. So y1 is the y coordinates of point A, y2 is the y coordinates of point B, and y3 is the y coordinates of point C. So now we will do we will write y1 is 1 upon AB plus y2 is 1 upon BC plus y3 is 1 upon CA divided by 3. This is what we have just written in terms of y1 plus y2 plus y3 here, ABC in terms of y1, y2, y3. So we will simplify it. We can write ABC as the LCM for above numerator. So after writing AB as numerator, LCM, we will be writing here as C plus here A and here it will be B. So basically divided by 3. So divided by 3 means it will be 3 upon ABC. So after more simplification, we can write y equals to A plus B plus C. We know the value of A plus B plus C, it is going to be plus 3. So here it is going to be plus 3 upon 3 times multiplied by ABC, and the value of ABC is minus 1. So it is going to be minus 1. So basically it is going to be minus 1. So y coordinates is going to be minus 1 because 3 will get cancelled. So y is equals to minus 1. So coordinates of centroid is going to be equals to, coordinates of centroid is x coordinate is plus 2 and y coordinates is minus 2. So basically finally we can write this coordinates of centroid of triangle ABC is going to be 2 comma minus 1. How we have achieved this? We have done nothing extra. We have done whatever we have learned till now. We have written the x coordinate as x1 plus x2 plus x3 upon 3, and here x1, x2, x3 is AB, BC, CA respectively. We have written those things divided by 3, and from the roots of the cubic equation we have known about the value of A plus BC plus CA. Similarly, we have done for y also. We have simplified it. We got this one, and we substituted the value of A plus B plus C as well as the value of ABC, and finally we got the result y coordinates as minus 1 for the centroid of triangle ABC. It was one of the good problem. So we have discussed the derivation of how to find the coordinates of a centroid if we are known the coordinates of all the points of a triangle ABC. Also, we have done some of the problems based on that. Now we are moving towards incenter. So if we have the knowledge of, if we have x coordinates, if we have the coordinates of point A, B, and C in a triangle ABC, and if you need to find the coordinates of incenter, then how we will do it? So we will start with what is incenter. Afterwards, we will move ahead. So just to recall, centroid is the point of intersection of all the medians of a triangle ABC. So now this is the time to learn incenter. Incenter. So what is incenter? So we have a triangle ABC, point A, point B, and point C. To understand incenter, we know the concept of angle bisector, which we have already learned in our in starting only as a prerequisite. So AD is the internal angle bisector. To be precisely clear, AD is the internal angle bisector, which means that AD divides angle BAC into two equal parts. That is, angle BAD is equals to angle DAC. So AD is the internal angle bisector. So if we need to write the definition of incenter, how we will do this? We will write incenter is the point of intersection of internal angle bisector The definition of these important points must be very much clear. Then only we can write their results. We will derive their results very easily. So incenter is the point of intersection of internal angle bisector. So AD is the internal angle bisector of angle BAC. Similarly, BE is going to be the internal angle bisector of angle CBA. So BE and AD are the internal angle bisector of this triangle ABC, which is intersecting at point I. Here I is the incenter. For centroid, the short form of centroid is G, and for incenter we take it as I. Similarly, if we will draw the internal angle bisector of point C, it will also pass through this point itself. and let's say it is coming here, and this point is going to be DEF. So basically AD, BE and CF are internal angle bisectors, and their point of intersection is I. Here I is the incenter. So I is the point of intersection of internal angle bisectors of a triangle ABC. So now we are known the definition of incenter. We need to find some of the results. How, if you know the coordinates of point A, let's say it is x1 comma y1, and B is x2 comma y2, and C is x3 comma y3. Now we need to find the coordinates of point I, that is incenter. So to understand that, now we need to understand, we have learned the concept of angle bisector theorem. We will apply here angle bisector theorem. From angle bisector we know that if AD is the internal angle bisector of an angle ABC of triangle ABC, it means that point D is going to divide side length BC in the ratio. Suppose this is side length, this is the side length of, here we can see that side length BC is going to be equals to A, side length AC is going to be equals to small b, and AB is going to be small c. So basically what is happening here is, this is the side length of this one, and B is the side length of AC, x1 comma y1. So we know from angle bisector theorem, I am writing here, from angle bisector theorem, BD upon DC is equals to C upon B. If AD is the internal angle bisector of triangle ABC, it means that point D is going to divide side length BC in the ratio C raised to B. That is, it is going to divide, D is going to divide side length BC in the ratio C raised to B. So applying section formula on side length BC, applying section formula on BC. So what we have is, this is point B with coordinate x2 comma y2, and point C with coordinate x3 comma y3, and this is the point D, let's say with coordinate x comma y as of now, and we know the ratio C raised to B. So D is dividing point side length BC in the ratio C raised to B. This we have achieved by using angle bisector theorem. Now we will apply a section formula on this problem, and we are very much aware of how to apply section formula. So we will write x coordinate as, x is equals to C multiplied by x coordinate of point C. So small c multiplied by x coordinate of point C, that is x3, plus B multiplied by x coordinate of point B, that is B into x2, divided by m plus n, that is B plus C in this case. So we got the x coordinate of point D, which is equals to C x3 plus B x2 upon B plus C. Similarly, we will write the y coordinate of point D, which is going to be equal to C multiplied by y coordinates of point C, that is C into y3, plus B multiplied by y coordinates of point B, that is B into y2, divided by B plus C. So we got the x and y coordinates of point D. So basically we can write point D as Cx3 plus Bx2 upon B plus C, comma Cy3 plus By2 upon B plus C. So we got the coordinates of point D. How we have achieved this? We know by angle bisector theorem that point D is dividing side length BC in the ratio C raised to B. From there we have write the coordinates of point D. Now our final aim is to find the coordinates of incenter. That is, we need to find the coordinates of point I, that is incenter. How we will do this? To know coordinates of point I, we need to apply section formula once again on the side length AD, but we should also know the ratio in which I is dividing AD. if we will know the ratio of how I is dividing AD, then we can easily apply section formula and we can write the coordinates of point I. So as of now we are not aware in what ratio it is dividing. So what we will do is, we are drawing the part ABD. We are drawing triangle AB and D. This is B, D and A. We have just taken the snapshot of triangle ABD and we have just drawn here. So we are applying once again angle bisector theorem. We know that this is I. Similarly, we know that BI is going to be the internal angle bisector of angle DBA of in triangle ABD. So we have taken this triangle here. Now we are known that this is the angle bisector. BI is angle bisector. BI is angle bisector of angle DBA. So BI is the angle bisector. Once again we are applying angle bisector theorem on this triangle ABD, which means that if it is the internal angle bisector, it means that we will write the side length. It means that this I is going to divide from, we are writing from angle bisector theorem. From angle bisector theorem, we know that AI upon DI is equals to, this is going to be BD. This is going to be let's say this is AB raised to BD. So basically point I is dividing side length AD in the ratio AB raised to BD. That is AI upon DI is equals to AB upon BD. Similarly here also we can write that point I is dividing side length AD in the ratio AB upon BD. AB is, so what we can write, AI upon DI is equals to, AB is equals to side length C divided by DI. DI is this length. Just a second. Sorry, AB upon BD. It is BD. It is BD. We need to find the length of BD. So how we will achieve this? So basically we have known that AI upon DI is equals to C upon BD. So we know the C is the ratio and BD is the side length of this part is the BD. We need to write BD in terms of C also. So how we will do that? Let's see. Now here we have B and C, and D is the point which is dividing in the ratio C raised to B. Also we know the side length of BC as A. This side length is A. So we need to find what is the portion BD is. So in order to find that, we know that B plus C into X, what we can do is, we can take Cx plus Bx is equals to A. Now point D is dividing side length BC in the ratio C raised to B. We will take Cx plus Bx equals to complete length, that is A. From here we can write X is equals to A upon B plus C. What is X basically? X is the 1 unit length on the side length BC. X is the 1 unit of length on the side length BC. So if we know the 1 unit of length, that is X unit of length is equals to A upon B plus C, then we need to write this part, that is C into X. What this value will be? Then we can write BD is equals to C into X, which is equals to C into value of X is A upon B plus C, which is equals to, we can write BD is equals to CA upon B plus C. So now we have value of BD in terms of ABC. So we can substitute here. So here we can write, what we can write here is AI upon DI, AI upon DI is equals to C upon BD. BD की value है, the value of BD is CA upon B plus C, that is B plus C will go into numerator. After solving we get AI upon DI is equals to B plus C upon A. What does this mean is, now we got the ratio, that is I is dividing side length AD in the ratio B plus C raised to A, which means that it is dividing in the ratio B plus C raised to A. So I is the point that is in center. which is dividing the angle bisector AD in the ratio B plus C raised to A. So now we can find the coordinates of point I very easily, because we know the coordinates of point D to be equals to this much, and we know the ratio in which point I is dividing side length AD. We can use section formula and we can easily write the coordinates of point I. So now we will write the coordinates of point I. Let's see how. So basically our problem has been converted to side length AD with coordinate x1 comma y1 and point D with coordinates this one. This already have been written here, and also we have the coordinates point I. We need to find the coordinates of point I, let's say x comma y, and we know the ratio, that is B plus C raised to B plus C ratio A. So easily we can write, applying section formula, we can write coordinates of point x is equals to B plus C multiplied by x coordinate of point D, that is B plus C multiplied by x coordinate of point B plus C multiplied by x coordinate of point D, and that is this one, cx3 plus bx2 divided by B plus C plus A multiplied by x coordinate of point A, that is plus A into x1 divided by m plus n. Here m plus n is B plus C plus A, so it will be B plus C plus A. After solving, we can write x is equals to B plus C will get cancelled out with B plus C. So basically we can write ax1 plus bx2 plus cx3, ax1 plus bx2 plus cx3 divided by A plus B plus C. So now if we have the coordinates of point A, B and C, then we can write the coordinates of incenter as ax1 plus bx2 plus cx3 plus upon A plus B plus C. Similarly we can write for y coordinates. So for y coordinates, what we can write, y is equals to B plus C multiplied by y coordinates of point D, that is B plus C multiplied by y coordinates of point D, that is y coordinates of point D is this one, cy3 plus by2 divided by B plus C plus A multiplied by y coordinates of point A, that is A into y1 divided by m plus n, that is B plus C plus A. After solving it, we can write y is equals to B plus C will get cancelled out with B plus C. Here we can write ay1 plus by2 plus cy3, ay1 plus by2 plus cy3 divided by A plus B plus C. So we got the coordinates of incenter of a triangle ABC if we are known about the coordinates of point A, B and C. So we can write the coordinates of x as ax1 plus bx2 plus cx3 upon A plus B plus C, and coordinates of y of incenter as ay1 plus by2 plus cy3 upon A plus B plus C. So now we are aware about the coordinates of centroid and the coordinates of incenter if we are aware about the coordinates of point A, B and C of any triangle ABC. So for coordinates of incenter, we have derived this one. We should revise this formula so that we can use and apply wherever required in any part of coordinate geometry. It will not useful for a straight line itself, but also it is useful for other coordinate geometry sections, for example circle, parabola, ellipse, hyperbola. There will be a mixed question there, it will be required in some of the problems, so we should aware about these results so that we can easily apply and get to the result. So we have got the coordinates of incenter. So we have problem based on the topic incenter. Very basic problem. We have coordinates A, B and C of triangle ABC. We need to find the coordinates of incenter of this triangle. So coordinates of point A is 0 comma C, and the coordinates of point B is 8 comma 12, and the coordinates of point C is 8 comma 12, and the coordinates of point C is 8 comma 0. We need to find the coordinates of incenter. So we have seen that first of all we will draw and write the result, whatever we are known about this problem. So A, B, C is the point. Coordinates is 0 comma 6, 8 comma 12, and the coordinates of C is 8 comma 0. So what we can write? First of all, we need to we have the incenter as ax1 plus bx2 plus cx3 divided by A plus B plus C comma ay1 plus by2 plus by3 divided by a plus b plus c. So we should know a, b, c. Since x1, x2, x3, y1, y2, y3 we are already known, but also we should know a, b and c. So what is a, b and c? A, b, c are the side length opposite to angle a, b and c respectively. So what ab is, so what is a? A is equals to length of, this is the a, this is b and this is c. So a is the side length of bc, which is equals to, what we can write, 12 x2 minus x1 का whole, x2 minus x1 whole square. So basically it will be 8 minus 8 whole square plus 12 minus 0 whole square. This is going to be equals to, in fact, 12 itself. So basically a is equals to 12. Similarly b can be written as side length ac. B is equals to side length ac, which is going to be equals to side length AC, which is going to be equals to 8 minus 0 whole square plus 6 minus 0 whole square, which is equals to 64 plus 36, which is going to be equals to plus 10. We are taking only positive sign because here we are writing that side length, that's why we are ignoring the negative part of minus 10. So B is equals to plus 10. Similarly C can be written as side length AB. Here we can write AB as, also the distance must be positive itself. So side length AB is going to be equals to 8 minus 0 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, 12 minus 6 whole square, 12 minus 6 whole square. It is going to be equals to 64 plus 36 again it is going to be equals to 10. So C is also going to be 10. So we are known A as 12, B as, sorry, we are just writing here A as 12, B is equals to 10 and C also 10. We are known ABC also, the coordinates x1, y1, x2, y2, x3, y3, all the coordinates are known to us. Now simply we can apply the formula here to get the coordinates of incenter. What we can do is, we can write I is equals to, first of all let's conclude the x coordinate, that which is equals to a times multiplied by x1. So a is 12, coordinates of x1 is x coordinate of point A, that is 0, plus b is 10 multiplied by x2, that is x coordinate of point B, that is 8, plus c into x3, c is 10, x3 is x coordinate of point C, that is 8 once again. So it divided by a plus b plus c, which is going to be 10 plus 10, 20 plus 12, that is 22. So basically it is 12 plus 10 plus 10. So x is equals to 80 plus 80, 160 divided by 10 plus 10, 20 plus 12, 20, sorry, 32. So this is going to be equals to, I guess this is half, so basically it is going to be equals to 5. So x is equals to 5. Similarly we can write y as a times multiplied by y1. So a is 12, y1 is the y coordinates of point A, that is 6, plus b is 10, y2 is going to be y coordinates of point B, that is 12, plus c is 10, y3 is y coordinates of point C, that is 0, divided by a plus b plus c, that is 12 plus 10 plus 10, which is going to be equals to 12 6 12 6 2 12, carry 1, 6 1 72, plus 12 10 120 plus 0 divided by 32, which is going to be equals to 192, I guess 192 upon 32, which is going to be equals to, if you divide by 8, it will be 8 2 16, carry 3, 30, 24, 4 times, it will be 6 basically. So y is equals to 6. So the coordinates of incenter of this triangle ABC is going to be 5, 6. So I is going to be 5, 6. The very basic problem, that we are known the three coordinates of triangle ABC, and we have been asked to find the coordinates of incenter. So easily we have calculated the distance A, B and C and applied the formula here, and we got the coordinates of incenter as 5, 6. So one of the basic problem for incenter. So we are having another problem here. The bisectors BD and CE of angle B and angle C of triangle ABC meet at the point I. We need to find the angle BIC if angle A is equals to 80 degree. So let us draw the diagram. What it is saying, we have point ABC of a triangle ABC. So basically the bisectors BD. So basically BD is the internal angle bisector of angle ABC, and CE, here it is CE. So CE is the internal angle bisector of angle ACB. What again given, meet at the point I. This is going to be known as I. Find angle BIC. We need to find this angle if we have been given this angle, that is 80 degree. So the problem is very much clear. We need to find this angle. We need to find angle BIC. So just try it by your own. After this, see the solution. So we know the angle sum property of a triangle, that sum of all the angles of a triangle is going to be 180 degree. That means angle A plus angle B plus angle C is going to be equals to 180 degree. This is angle sum property of a triangle. Angle sum property, which states the sum of all the angles of a triangle is going to be 180 degree. So if we will divide by half throughout the equation, we will be getting half of angle A plus half of angle B plus half of angle C is going to be equals to 90 degree. This is going to be the equation number 1. Also we have been given the angle A, so we will use it here. So we can write angle A 80 degree by 2, that is 40 degree. So basically angle B by 2 plus angle C by 2 is equals to 90 degree minus angle A by 2, that is equals to half of angle A is 40 degree. So it is going to be equals to 50 degree basically. So half of angle B plus half of angle C is going to be 50 degree. This is going to be our first equation. So now we are aware about half of angle B plus half of angle C, which is going to be equals to 50 degree. So as we know that BD and CE are internal angle bisectors, as it has been already mentioned in the problem that the bisectors BD and CE, it means this is angle bisector. So in triangle BIC, what we can write as angle IBC plus angle ICB plus angle BIC is equals to 180 degree, again using angle sum property of a triangle. So angle IBC is basically half of angle B. This is angle IBC and this is half of the complete angle B, which we have been taken from triangle ABC. So basically it is a half of angle B plus this is half of angle C. ICB is basically half of angle C. So this is half of angle C plus angle BIC, which we need to calculate. So from here we can write angle BIC is equals to 180 degree minus, we know the value of half of angle B plus half of angle C, which is equals to 50 degree from equation 1. So we can directly write 180 degree minus 50 degree. So we can write angle BIC is equals to 130 degree. This is our required answer from equation 1. So we have subtracted 50 degree because sum of half of angle B plus half of angle C is 50 degree, which we have taken from equation 1 itself. So finally we got the angle BIC equals to 130 degree as a result. So as of now we have concluded what is centroid, what is the definition of centroid, what is median, how centroid divides median, all the derivations of these things. Also we have concluded what is the point of coordinates of any centroid if we are known the coordinates of points A, B and C of a triangle ABC. As well as we are known, apart from that we have taken some examples based on centroid. After that we have taken point into consideration for incenter. We have seen what is angle bisector theorem. Also we have seen how to derive to find the coordinates of incenter of a triangle ABC if we are known about the coordinates of point A, B and C. So also we have taken some of the problems based on centroid and incenter. So rest all the points, that is excenter, centroid and circumcenter, we are going to take in another lecture. Till then you just revise all the topics which we have discussed today. All the topics are very much important because it is going to be one of the base for us coordinate geometry, because we are going to see all these things lesser or more incoming topics when we will be getting the mixed problem in advanced or JEE mains or any other competitive exam. We will be able to see all these topics very frequently. So very important topic. Please go through all the derivations. Derivations are not that much important. Once again, I'm saying, but the results which have been derived, it is going to be play a vital role. If we have memorized the result, we are going to solve our problems very quickly, and we will reduce our time while giving our examinations. So please go through. We will meet again with rest of the points. Thank you. Bye bye. Take care.